Today we're going to talk about an arithmetic sequence and then an arithmetic series. An arithmetic sequence is pretty simple. It's a sequence that looks like this. I have my terms here, a, and a plus d, and a plus 2d, and a plus 3d. A is the first term, and d is what's called the common difference. The common difference is found by subtracting any term from its succeeding term. So it's the difference between the two terms, between a and a plus d, between a plus d and a plus 2d. So, for example, if we want to find the next three terms, I have negative 12, negative 1, and 10. The first thing you have to do is find the common difference, and then you add that common difference to each successive term. It's kind of common sense. So, my common difference d is going to be negative 1 minus a negative 12, so that's negative 1 plus 12, which gives me a common difference of 11, which means the next three terms is going to be 10 plus 11, so it's going to be 21, and then 32, and then 43. So the common difference is just the difference between two successive terms. So you'll always have the same amount of gap between each term in an arithmetic sequence. Now, if I want to find a specific term, there's a formula I can develop to do that, because let's say I have a sequence and I want to find like the 100th term. You don't want to sit there and add the common difference 100 times. That's not a very efficient way of doing things, and we don't want to do that in pre-calculus. So if I have a sub 1, I know a sub 2 is going to be a sub 1 plus the common difference. I know a sub 3 is going to be a sub 2 plus the common difference. So I can take this expression for a sub 2 and substitute it in. And what I can end up with, a sub 3 is actually a sub 1 plus d plus d. And if I simplify it, a sub 3 ends up being the first term plus 2 of the common differences. And that's a standard pattern. I can always start with the first term, and then to that first term I add a multiple of the common difference to get to the term I want. So the pattern here, if I want the third term, this number is going to be 2. If I want the fourth term, that number is going to be 3, and so on. So the formula is a sub n, the nth term, is going to be the first term plus n minus 1 times the common difference. Okay, so just as a reminder, that's the first term. That's the common difference. So that's one of two formulas we're going to work with today. So we're going to do a couple of examples to show you how this works. They're fairly straightforward. In the first one, I want to find the 68th term of this sequence, 16, 7, negative 2, dot, dot, dot. So the dot, dot, dot tells you that the pattern repeats. And if I look, the gap between the 16 and the 7 and the negative 2 should be the same. It should be the common difference. So let's figure that out first. The common difference here is going to be 7 minus 16, and that's going to be negative 9. So your common difference can be negative as well. And when your terms are decreasing, then the common difference has to be negative. So I just use my formula, a sub n is equal to a sub 1 plus n minus 1 times d. I'm trying to find the 68th term, and the first term is 16. So a sub 68 is equal to 16 plus, this would be 67 times negative 9. That is very straightforward. You put that in your calculator and you come up with a number, negative 587. You don't want to do that by hand. You want to learn the formula to get this done. So the formula is this guy. A sub n is equal to a sub 1 plus n minus 1d. Now we can do the same thing with variables. They're just along for the ride. I want to find the 71st term. Here's my first term, If I looked at the common difference in this case is going to be negative t plus 6 minus negative t plus 2. Well, I have a negative t minus a negative t, so that's going to add to 0. 6 minus 2 is going to be 4. So my common difference is 4. And then the rest is just using the formula. A sub 71 is equal to the first term, which is negative t plus 2 plus 70 times 4. So the rest is numeric, and the negative t is just along for the ride. A sub 71 is negative t, and this ends up being 70 times 4 is 280 plus another 2 plus 282. So that's how that works. We're going to look at a classic application problem for an arithmetic sequence, and there aren't a lot of application problems really, but this one is a classic. If, let's say I have an auditorium and I have 20 seats in the first row, and each row increases by 2 seats. How many seats are in the 19th row? I'm not looking for the total number of seats in the auditorium. I want to know how many seats are in the 19th row. So here's how you look at this. There are 20 seats in the first row, so the first row is a sub 1. So a sub 1, that value is 20. I'm looking for a sub 19, and I'm increasing by 2 each time. So that is my common difference. So I have all the things I need to use the formula. Remember, the formula is a sub n is equal to a sub 1 plus n minus 1 times the common difference. A sub 19, I want to know how many seats are in the 19th row. The first row has 20 seats, so the common difference is 2, and I'm looking for n minus 1 is 18 times 2. So there are 56 seats in the 19th row. That's an example of how you can use an arithmetic sequence to solve an application problem. So now we're going to talk about an arithmetic series. And we call an arithmetic series, that's the indicated sum of an arithmetic sequence. So the indicated sum is the string of numbers that represents the sum, but it isn't actually a single number. So let me explain. If I have an arithmetic sequence, 3, 8, 13, 18, 23, the equivalent arithmetic series is 3 plus 8 plus 13 plus 18 plus 23. This is an indicated sum. And we can do this generically. If I have a generic arithmetic sequence, then the arithmetic series is a1 plus a sub 2 plus a sub 3 plus, the pattern goes on to the nth term. So that's a series. An arithmetic series is the indicated sum. Now if we actually wanted to calculate the sum, we have 2 formulas we can work with. And depending on what we have will determine the choice of formula that we use. So the first one is we represent the sum with a capital S. S sub n. Okay, and this one, n is the total number of terms that you're adding up, so it's n over 2. And then in here, it's 2a sub 1 plus n minus 1 d. Now I think your book has a nice derivation of that if you ever want to know where that sum comes from. But most kids don't listen when I show them, so that's why I'm just gonna give it to you this year. So there's my formula. The sum is n is the number of terms, a sub 1 is still the first term, and d is still the common difference. Now, there's another way to write this because we know that a sub 1 or a sub n is equal to a sub 1 plus n minus 1d. So I know this a sub n is equal to an a sub 1 plus n minus 1 times d. So if you look at this, here's the n minus 1 times d, and I can pull one of these guys out. So I really have a sub 1 plus a sub 1, because that's 2a sub 1, plus n minus 1 times d. So the second way to write this sum is a little bit simpler. S sub n is equal to n over 2 times a sub 1 plus a sub n. That's much easier, but you have to know the first and the last term in order to use that second one. Up here, you don't need to know the last term, you need to know the common difference. Now, if you use this formula, you've got to be careful. Most kids forget that it's 2a sub 1, not just a single a sub 1. The single a sub 1 is down here when you simplify. So you are going to have to memorize these formulas as well. So we're going to work an example. We're going to find the sum of the terms in the series. Negative 14 plus negative 8 plus negative 2 plus 142. So our terms are negative 14, negative 8, and negative 2 on up to 142. So take a minute and think about what you know. You should probably pause this for a minute and write down what you can get. Write down what you know. And then we'll start again. So, what you should find out, what you should know is we have a sub 1. A sub 1 is negative 14. We also have a sub n. A sub n is 142. So that makes things a little bit easier. I don't know how many terms are in the series, though. But I can get the common difference. The common difference in this case ends up being 6. So we need to know, this is going to be a two-part problem because we need to find n in order to find the sum. So in order to find n, I go back to my original formula. A sub n is equal to a sub 1 plus n minus 1 times d. I have everything else. I have a sub n, I have a sub 1, I have d. I can solve for n. So I'm going to substitute in. A sub n is 142. A sub 1 is negative 14 plus n minus 1 times 6. In order to solve this, I would add 14 to both sides, and then I would probably distribute the 6 and eventually solve for n. So when you finish, when you solve for n, you get 27, but you should work through the algebra yourself to make sure you understand how to do that. Now that I have n, my formula is very simple. S sub 27 is equal to 27 over 2 times negative 14 plus 142. And then you process all of that, and you end up with a sum of 1,728. That's not something you would want to do by hand by just adding all these things up. It's much better to use the formulas. I'm going to finish here with one example and then example 3, and then we'll work some other examples in class. An auditorium, it's another auditorium problem. An auditorium has 50 rows of seats with 30 seats in the first row. The seat count increases by 2 with each consecutive row. Find the total number of seats. So now I'm not looking for the number of seats in a row. I'm looking for the total number of seats in the auditorium. So you should pause this and take a minute and write down what you know and see if you can work through it. Now that you've done that, let's take a look. An auditorium has 50 rows of seats. So each row is a term in a sequence, in the arithmetic sequence. So if I have 50 rows, that means n is 50. Okay? And a sub 1 is going to be 30. The other thing I know is the common difference. I'm increasing by 2 in each row. So that's enough to find the number of seats. I can use the formula, the first formula that I gave you. So the sum of the 50 rows is going to be 50 over 2, because it's n over 2, times 2 times a sub 1, plus n minus 1, which is 49, times 2. So you substitute all of that in, and you end up with 3,950 auditorium seats. So if you didn't work through this problem by yourself, you should go back and make sure you understand where all those numbers came from. And we're going to be working more of these problems in class.